Imagine the warmest homes ever engineered for the harshest Arctic winters, and picture them without a single pane of glass, without a chimney rising into the sky, without fiberglass batting stuffed behind drywall, and without any of the machinery we now consider essential to staying warm. And then imagine that these homes, built 1,000 years ago from little more than earth, grass, timber, and fire, still managed to outperform a surprising number of houses standing today. And once you accept that possibility, the entire popular image of Viking life begins to crumble, because for generations that image has been painted in the same bleak strokes. Snow piled endlessly against crude wooden walls, wind screaming through every gap and crack, families huddled in smoke-choked darkness, coughing through the winter months, simply trying to survive one more night before spring finally arrived to rescue them. And this picture feels intuitive, it feels like common sense. It fits the assumption that anything built before modern engineering must have been primitive and miserable by comparison, and yet the archaeological record tells a very different story. A quieter story, and in some ways a far more unsettling one, because it turns out that Viking communities did not simply endure winter the way we imagine a shipwrecked sailor might endure a single terrible night. They lived inside winter, season after season, generation after generation, for centuries in some of the coldest, windiest, most resource-scarce environments on the planet, from the fjords of Norway to the volcanic plains of Iceland, to the icy edges of Greenland. And they did this not through brute endurance or sheer stubbornness, but through a form of engineering so subtle, so cumulative, and so deeply systemic that it rarely gets credited as engineering at all. And there was no magic involved in any of this, no heroic nightly battle against the elements, no endless mountain of firewood being fed into a fire that somehow kept an entire village from freezing. Instead, there was a way of thinking. Philosophy of building embedded so deeply into the architecture that every single element of a Viking home worked in concert with every other element: the ground beneath the house, the thickness and composition of the walls, the way air was allowed or forbidden to move through the structure, the presence and arrangement of human and animal bodies, even the slow, deliberate behavior of smoke drifting beneath a roof. None of it existed in isolation, none of it was accidental. Nothing about it was left to chance, because heat in this world was never treated as something abundant or wasteful. Wind was never casually invited indoors, and energy in every form it took was never assumed to be limitless. And this is really the heart of the whole story, because to the Vikings, winter was not framed as an enemy to be defeated through force or willpower. It was understood as a condition to be managed carefully, patiently, and intelligently. In a world where cold dominated the majority of the calendar year, where usable fuel was often scarce and hard won, and where a single gust of wind could strip away more warmth in seconds than an hour of careful fire tending could replace, the Vikings found themselves asking a fundamentally different question than most of us ask today. They did not ask how to generate more heat, they asked how to lose less of it, and that single reframing, that one shift in perspective, rippled outward into everything they built, from the dense, root-woven soil they packed into their walls to the slow, low curl of smoke drifting beneath their rooflines. And what emerged from this way of thinking was not merely a shelter in the simple sense of four walls and a roof. It was a complete system, a deliberately engineered mechanism whose entire purpose was to keep human life going even as the world outside did everything in its power to freeze it into stillness. And to understand this system properly, it helps to start with the building at its center, the Longhouse, because the Viking Longhouse was never really a building in the way we think of buildings today. It was not a static, sealed-off object designed purely to separate the people inside from the hostile world outside. It functioned instead like a living organism, breathing, adjusting, and responding to the needs of everyone within it. And archaeological remains uncovered across Scandinavia, Iceland, and Greenland reveal structures that stretched astonishingly far, 20 meters in some cases, 40 in others, and in the largest examples more than 80 meters from end to end. Entire communities living together beneath a single continuous roof, families sleeping side by side along the walls, elders working close to the warmth of the central hearth, children weaving through shared communal spaces as daily life, labor, rest, storytelling, and survival all unfolded together under one unbroken structure. And this was not simply crowding born out of desperation or a lack of resources. This was deliberate, intentional design, because the Vikings understood a basic biological truth that we too often overlook today. Human bodies generate heat constantly, simply by existing, simply by breathing and moving and living, and by concentrating dozens of people together within one enclosed volume of space. Viking builders effectively transformed population density itself into a renewable thermal resource. Warmth in this arrangement was not hoarded by any single individual. It was shared, redistributed, and conserved collectively, so that no one person was ever left to fight the cold entirely alone. And even the physical shape of the Longhouse reflected this same underlying logic, its walls curving gently outward and back rather than meeting at harsh right angles, echoing unmistakably the hulls of Viking ships, allowing fierce winter winds to slide around the structure rather than slamming directly into a flat, resistant face. And these curved forms were never accidental artistic flourishes, they were the direct result of practical maritime knowledge, because Viking builders were, first and foremost, sailors, people who had spent generations learning how to move through hostile, unpredictable environments at sea, and they carried that hard-won knowledge ashore with them. applying the same principles of hydrodynamics and wind resistance to the architecture of their homes, so that the house itself did not attempt to resist the wind through sheer stubborn strength. It worked with the wind, guiding it gently around the structure instead of standing rigidly against it. And inside these curved, communal walls, every single activity taking place within the household, sleeping, cooking, weaving, tool-making, storytelling, child-rearing, all of it fed back into one unified thermal system, much like a ship's crew huddled together and working in coordinated rhythm to survive a violent winter storm out at open sea. Everyone living beneath that long, curved roof became, whether they realized it or not, an active participant in a larger shared survival mechanism. And in this sense, the building truly did live, because it only functioned as intended so long as the people inside it continued living, working, and moving through their daily routines together. And this brings us to another point where popular imagination diverges from historical reality. Because despite how Viking homes are so often depicted in films, thick stacks of heavy timber logs forming solid cabin walls, the truth in many Viking regions, especially Iceland and Greenland, was almost the opposite. Wood there was rare, fragile, difficult to transport, and far too precious to waste on thick walls that would bleed heat straight into the wind anyway. Trees took generations to reach usable size, while winter arrived reliably every year without fail. So the Vikings turned instead to completely different material lying directly beneath their feet in near limitless supply: the earth itself. And massive blocks of turf were carefully cut straight out of the ground, thick layers of soil bound tightly together by dense, interwoven networks of grass roots. And these blocks were then stacked methodically into walls that could reach an astonishing 2 meters in thickness at their base, gradually narrowing as they rose toward the roofline. And the resulting structure was anything but crude or accidental. It was deliberate, remarkably stable, and thermally efficient in ways that modern observers often fail to appreciate at first glance. Because the real brilliance of turf construction lies not in its outward appearance but in simple, elegant physics. Soil, it turns out, is riddled with countless tiny pockets of trapped, motionless air, and still, trapped air happens to be one of the most effective natural insulators known to exist. Long before anyone had developed the scientific instruments or vocabulary to measure insulation values in controlled laboratory conditions, Viking builders had already grasped this principle intuitively. Through generations of accumulated trial, observation, and lived experience, they understood in a deeply practical sense that heat stays exactly where air is prevented from moving freely, and so their turf walls effectively became natural thermal batteries. Storing warmth and releasing it slowly over time, earth blocked the relentless wind from ever reaching the interior. Tightly woven roots locked the entire structure together into a single cohesive mass, and countless microscopic air pockets slowed the escape of heat to an absolute crawl. And remarkably, over time, fresh grass would actually regrow directly across the surface of these turf walls, further tightening and reinforcing the structure with each passing season. Until eventually the house was no longer simply placed upon the surrounding landscape, it had in every meaningful sense become an inseparable part of it. And what the Vikings had built through this process did not separate them from the natural world surrounding their villages. It deliberately harnessed the raw materials and physical properties of that natural world to keep human beings alive through the harshest months of the year. Yet even the best turf walls and the steadiest fire were never quite enough on their own to keep a Viking household alive through the depths of winter. Because inside the Longhouse, human beings did not live in isolation from the animals that sustained their economy and diet. During the coldest stretches of the year, cows, sheep, goats, and horses were brought indoors, occupying substantial sections of the same structure where people slept, worked, and gathered each evening. And to modern sensibilities, this might initially seem crude or unsanitary, but to the Vikings it represented a remarkably precise form of energy management. Because a living, breathing animal functions essentially as a highly efficient heat engine. A single cow, through nothing more than ordinary metabolic processes, produces roughly as much continuous body heat as several modern electric space heaters running simultaneously around the clock. And when that output is multiplied across an entire herd sheltered indoors, the result is a steady, dependable, self-sustaining source of warmth that never runs out of fuel, never requires constant tending, and never once stops working through even the longest, darkest winter nights. And the Longhouse itself was carefully designed to take full advantage of this biological reality. Livestock areas were consistently positioned at a slightly lower elevation than the areas where humans lived and slept, and as the animals breathed, moved, and generated heat throughout the day and night, that warm air naturally rose upward through the structure, drifting steadily into the elevated spaces where families gathered, worked, and rested, meaning that heat moved precisely to where it was needed most without requiring any conscious effort or mechanical intervention whatsoever. No pipes were needed. No bellows, no additional fuel burned purely for the sake of redistributing warmth, just simple biology working hand in hand with careful architectural planning. And through this elegant arrangement, the Vikings demonstrated a level of understanding that much of modern residential design has quietly forgotten, namely that warmth does not always need to be manufactured entirely from scratch. It can instead be shared, cleverly redirected. and sustainably maintained through living systems already present and available within the household itself. And in a very real, tangible sense, inside the Longhouse, warmth quite literally walked on four legs and breathed steadily alongside the very people it worked continuously to protect. And beyond the challenge of generating and distributing heat, the Vikings also had to contend with an even more dangerous adversary, one that modern architectural thinking still frequently underestimates. Because cold alone by itself rarely proves fatal to a healthy human being, it is wind-moving air that represents the fastest and most efficient way to strip warmth away from both the human body and the structure sheltering it. And a calm, perfectly still, freezing night can often be survived with relative ease, while a windy night at the very same temperature can drain body heat and structural warmth far faster than any fire could realistically hope to replace it. And the Vikings clearly understood this critical distinction on some deep practical level, because Viking architecture consistently focused not on directly battling raw temperature itself, but rather on carefully controlling and restricting airflow at every possible point. Drafts of any kind were treated as a genuine structural threat, something to be actively minimized rather than passively tolerated, and this is precisely why Viking homes featured almost no windows whatsoever. Not because Viking builders lacked the necessary skill, creativity, or resources to include them, but because every single opening in a wall represented an inherent weakness in the home's overall thermal defenses. Glass, where it existed at all in this era, remained exceptionally rare and prohibitively expensive, but even setting cost entirely aside, windows would still have functioned as literal holes punched directly through a house's thermal armor, and so quite deliberately. Darkness within the home was consistently judged to be a far safer and more practical trade-off than direct exposure to the freezing air outside. Walls were built exceptionally thick, and were sealed as tightly as available materials and technique would reasonably allow, and entrances themselves were kept deliberately low and narrow, often forcing anyone entering or leaving the structure to physically bend down or duck their head as they passed through the doorway. And this was never intended as some symbolic gesture of humility or respect. It was pure practical physics at work, because a smaller, more constrained opening naturally meant that significantly less freezing outside air could rush directly into the living space with each entry or exit, and correspondingly, far less precious warm air was allowed to escape outward alongside it, and many longhouses went even further than this simple measure, incorporating a short entry passage or vestibule directly in front of the main living area, an intentionally unheated buffer zone specifically designed to absorb and dissipate the initial shock of outside air before it ever had the chance to fully reach the warmer living space beyond, functioning essentially as an early primitive version of what we might now recognize and describe as an airlock, centuries before that particular engineering concept ever received a formal name or definition. And inside a properly constructed Viking home, warmth generated through fire, animal body heat, and simple human presence was carefully and deliberately guarded at every single turn, never allowed to escape easily or carelessly through poorly designed openings. And at the very physical and social center of the Viking longhouse burned a fire unlike almost anything found within a typical modern home today. This was not a small fireplace tucked neatly against a single wall, contained within a narrow masonry alcove. It was instead a long, open, continuous hearth that ran directly through the structural heart of the entire building, in some particularly large examples stretching more than 10 meters from one end to the other, effectively functioning as the entire household's thermal backbone, and carefully arranged stone-lined pits positioned directly beneath this long fire would steadily absorb heat as the flames burned throughout the day, then slowly and gradually release, that stored warmth back into the surrounding space over the course of many subsequent hours, continuing to provide meaningful warmth even long after the visible flames themselves had noticeably faded or died down entirely. And in regions where usable trees remained scarce or altogether absent, peat was frequently used instead of traditional wood as the primary fuel source, burning far more evenly, steadily, and for considerably longer stretches of time, providing dependable warmth without demanding constant, hands-on attention throughout the night. And this central hearth accomplished far more than simply warming the immediate surrounding space. It also provided essential light throughout the long, dark winter months. It served as the primary cooking surface for the entire household. It helped dry wet clothing and equipment after long days spent outdoors, and it naturally became the undisputed social center of daily household life. The specific place where people consistently gathered together to work on various tasks, to share meals, to tell stories passed down across generations, and eventually to settle down and sleep each night, meaning that the entire rhythm of daily household life organized itself quite naturally around this single central fire. And yet, despite the obvious presence of continuous open flame burning throughout each day, there was conspicuously no chimney built into the roof structure to vent the resulting smoke directly outside, and by contemporary modern standards this glaring omission should have proven genuinely deadly. One might reasonably assume that smoke would inevitably fill the entire enclosed structure, gradually suffocating everyone sheltering inside. But Viking builders clearly possessed a sophisticated practical understanding of airflow dynamics and heat behavior, an understanding detailed and nuanced enough to make this seemingly dangerous arrangement function safely and effectively over long periods of continuous use. because the fire itself was never treated as some isolated, standalone feature bolted onto an otherwise unrelated structure. It was instead fully and deliberately integrated into the building's larger overall system. One specifically engineered to retain warmth efficiently, while simultaneously keeping any associated dangers reasonably well controlled and manageable. And inside the Viking Longhouse, rising smoke did not simply vanish upward and disappear the way we might instinctively expect. Instead, it gradually rose and steadily accumulated directly beneath the roofline, forming a distinct, persistent layer that hovered above the primary living space below. And this was never viewed as an unfortunate design flaw to be tolerated. It functioned instead as a genuinely essential component of the overall thermal system, because as the fire burned steadily throughout each day and night, the resulting hot smoke formed a warm insulating layer positioned directly beneath the ceiling, effectively creating an invisible thermal blanket that helped trap accumulated warmth down at the lower level where people actually lived, worked, and slept each night, ensuring that valuable heat was never simply allowed to escape freely upward and outward into the frigid winter air above. And simultaneously, this same rising smoke served an entirely separate and equally important secondary purpose within the household, because fine soot particles gradually settled and accumulated directly onto the home's wooden beams and structural roof supports, coating them steadily over time in a thin yet remarkably effective protective layer. And this accumulated soot coating actively helped drive away various destructive insects that might otherwise have infested and weakened the timber structure. It noticeably slowed the gradual accumulation of damaging moisture within the wood itself, and it measurably delayed the onset of structural rot that would otherwise have threatened the building's long-term stability and safety, meaning that the entire house was, quite literally, being carefully preserved and maintained from the inside out, day after day. Purely as a natural byproduct of ordinary daily fire use, and Viking builders clearly understood and carefully managed this entire delicate process, incorporating adjustable roof vents specifically designed to allow smoke to escape outward whenever genuinely necessary, though critically never allowing it to escape all at once in one sudden rush. And throughout the depths of winter, these particular vents were typically kept almost entirely closed, meaning that overall interior air quality was quite deliberately sacrificed to some meaningful degree in direct exchange for maximizing retained warmth throughout the structure. And the house, as a direct result of this careful trade-off, simply did not breathe freely or continuously the way many modern buildings are specifically designed to do today. Instead, it breathed slowly, deliberately, and with careful restraint, because within this particular cultural and environmental context, basic day-to-day comfort was quite clearly treated as a secondary consideration, while fundamental physical survival through the long winter months was unmistakably prioritized above absolutely everything else. And turning now specifically to the roof itself, within Viking architecture the roof mattered every bit as much as the surrounding walls, and in certain important respects it arguably mattered even more. Because it was never conceived of or constructed as merely a thin protective barrier meant only to keep out occasional rainfall, it functioned instead as an entire living layer of comprehensive structural protection. And beneath the visible outer surface, carefully overlapping sheets of birch bark were meticulously laid down across the roof structure to create a genuinely effective waterproof barrier or skin. And directly on top of this waterproof layer, thick additional layers of turf were then carefully stacked and compressed steadily under their own considerable accumulated weight. And once fully completed, the resulting roof structure could easily weigh several total tons, an amount of weight that, rather than representing some unfortunate structural burden to be minimized, actually functioned as highly effective built-in insulation, because this substantial accumulated mass served to significantly slow the ongoing escape of interior heat. To meaningfully stabilize overall interior temperatures across day and night cycles, and to firmly press the entire structure downward and securely into the surrounding ground, effectively anchoring it firmly in place against the relentless force of persistent winter winds sweeping across the open landscape. And as a direct result, sudden and potentially dangerous temperature swings were noticeably softened and moderated, while accumulated interior warmth was allowed to linger measurably longer than it otherwise would have within a lighter, less substantial roof structure. And over time, fresh grass would naturally take root and spread steadily across the exposed roof surface itself, with the resulting root systems binding the various turf layers firmly together, effectively sealing any remaining small gaps while simultaneously shielding the underlying birch bark layer below from direct exposure to harsh sunlight, driving rain, and gradual seasonal decay, meaning that the roof effectively repaired and maintained itself over time, largely just by being sensibly left alone to function naturally. And the completed house structure, as a direct result of all these interconnected design elements, did far more than simply provide passive shelter for the people living inside it. It actively changed and adapted along with each passing season, responding naturally to shifting environmental conditions throughout the year, meaning that what ultimately stood beneath the accumulated winter snow was never really a static, lifeless structure in any meaningful sense, but rather a genuinely living extension of the surrounding natural landscape itself. And this brings us naturally to snow, because where contemporary modern homeowners typically rush outside to immediately shovel away accumulated snow from around their houses, the Vikings, by clear contrast, quite deliberately allowed substantial snow to remain exactly where it naturally settled, because they clearly understood something fundamental about the true nature of snow that many people today still consistently overlook or misunderstand, namely that snow functions not primarily as some hostile burden or obstacle to be cleared away as quickly as possible, but rather as remarkably effective natural insulation in its own right. Snow, it turns out, effectively traps countless tiny pockets of still motionless air between its individual crystalline structures, making it one of the single most effective natural insulating materials readily available anywhere on Earth. And as successive winter storms steadily piled drift after drift of accumulated snow directly against the exterior walls and roof surfaces of Viking longhouses, these thick accumulated layers effectively sealed remaining small cracks, physically blocked penetrating wind from reaching the structure directly, and significantly slowed the ongoing loss of valuable interior heat, meaning that what might initially appear to an outside observer to resemble complete burial beneath the snow was, in physical reality, genuine and highly effective protection. And entire Viking villages could, under the right seasonal conditions, essentially vanish almost completely beneath substantial accumulated snowdrifts, leaving only small entrance passages and thin, steady columns of rising smoke visible against the surrounding white winter landscape, and beneath that seemingly harsh frozen exterior armor of packed snow. The actual measured temperature, immediately near the interior walls, typically hovered remarkably close to the freezing point, representing a dramatically warmer and more stable condition, when directly compared to the brutally cold ambient air temperatures found immediately outside the structure. And this substantial insulating layer of accumulated snow effectively absorbed and moderated sudden temperature swings that might otherwise have threatened the structure's interior stability. Penetrating wind was effectively locked entirely outside the structure, and accumulated interior warmth was consistently and reliably retained within, meaning that the house itself no longer stood fully exposed and vulnerable to the harsh realities of winter weather. It had instead become something more accurately described as wrapped securely inside it, thoroughly protected by its own accumulated environmental surroundings, and beyond those carefully constructed layered walls of packed earth, dense turf, and accumulated protective snow, the punishing winter cold was successfully and reliably kept precisely where it fundamentally belonged, safely outside the living space. And so when we finally step back and ask why Viking villages never simply froze solid through the depths of these brutal northern winters, the answer turns out to have remarkably little to do with generating some seemingly endless supply of raw heat, even less to do with burning noticeably more fuel than any of their historical contemporaries elsewhere in the world. Instead, the real answer lies in something the Vikings clearly understood at a fundamental level that modern society has largely forgotten or actively overlooked, namely that meaningful warmth is never something that simply gets created from nothing. It is instead something that must be deliberately and carefully preserved through intelligent, coordinated design. Because the Vikings never really thought about their homes purely as isolated buildings in any narrow modern sense, they thought instead in terms of complete interconnected systems, where every single individual element genuinely mattered to the functioning of the whole. Dense earth carefully packed into thick supporting walls, domesticated animals deliberately sharing enclosed living space with human occupants, open fire carefully embedded directly into supporting stone structures, rising smoke deliberately held and trapped beneath an enclosing roofline, accumulated snow intentionally allowed to settle naturally and effectively seal the entire structure, and even basic everyday human behavior itself consciously shaped and adapted around the practical limits imposed by winter conditions. And crucially, none of these individual elements ever functioned successfully in complete isolation from all the others. Heat throughout this entire integrated system was consistently slowed down, actively shared among occupants, continuously recycled wherever possible, and carefully protected at absolutely every single stage of the process, meaning that unnecessary heat loss was proactively minimized long before any additional replacement warmth ever actually became genuinely necessary. And as a direct result of this holistic, deeply integrated approach, the completed house itself effectively became a natural extension of its surrounding environment, rather than functioning as some artificial, isolated barrier deliberately built to stand entirely apart from that same environment. And their carefully engineered homes, quite remarkably, never really fought directly against the forces of nature surrounding them. Instead, they consistently aligned themselves closely and intelligently with those same natural forces. And by consistently approaching the challenge of winter survival in exactly this thoughtful, integrated way, Viking communities across Scandinavia, Iceland, and Greenland managed to successfully create genuinely livable environments fully capable of sustaining ongoing human life even within some of the harshest, most unforgiving physical environments found anywhere on the planet. Environments where a great many comparable modern buildings would likely struggle significantly to function reliably without a continuous, uninterrupted supply of external mechanical energy input. And importantly, none of this remarkable historical achievement should be dismissed or mistaken as mere legend. And none of it should be casually written off as simple exaggerated myth either. This represents something considerably more substantial and meaningful than either of those dismissive categories. This represents genuine primal heritage, the largely forgot engineering wisdom quietly inherited from humanity's own deep historical past, wisdom that modern society has, in many important respects, allowed itself to gradually forget over the intervening centuries. And ultimately, this entire remarkable story leaves us facing one final, quietly persistent question worth genuinely sitting with, a question that continues to feel deeply relevant even today. What other essential forms of practical wisdom have we, as a modern society, similarly forgotten along the way? Forms of knowledge that once reliably kept earlier generations of human beings alive through conditions considerably harsher than most of us will ever personally need to face.